Hello, thank you for coming. Today we have a really interesting topic to discuss, and it's known as zero-knowledge architectures. Who knows what the hell it means? Okay, I see one hand, two hands. Raise your hands again, please. 1, 2, 3, 3.5, 4. Okay, no worries. I'm here to answer this question. And today we will define what zero-knowledge architectures are, we will describe its core properties, and instead of diving into super hardcore cryptography, I will show you some practical examples. And we will discuss those examples and how we can build our own zero-knowledge architecture. But before we start, for those of you who see me first time, I won't ask you to raise your hands, be silent. So for those of you who see me first time, my name is Anastasiia and I'm a software engineer. I do write iOS applications and server-sides for them, and I talk a lot about security. Now I'm working in security companies, so I will talk even more about security. And this talk is a small talk, really small and tiny talk in a whole layout of security talks I gave. It may be a little bit complicated for you, so I don't mind if at some point you decide to go and grab a coffee, but I will remember faces. But anyway, I don't like to tell some basic things again and again and again. I'm sure that you already have a good background to talk about advanced stuff, right? So let's play a game. How do you think what sensitive data is? How you will describe it? Just shout a word or two. Sensitive data is? Personal information. What else? Credentials, right? Card details, yeah. Sorry? Privacy, right. Basically, you see, we all have different views on what sensitive data is, and actually we can describe it in a different ways. But it's just something, some kind of data you want to keep private and you want to protect. Let's move forward. What E2EE means? Okay, a tip for you. It means end-to-end encryption. What end-to-end encryption means? Safety. Yeah, well, at some point, yeah, but anything else? No middleman, yeah. Well, basically the idea is really simple. End-to-end encryption means that there are clients and somewhere, something in between, a server, an environment, some networks, and messages are being encrypted on the clients and can be decrypted on the clients. So no matter what is in between, it cannot read the messages. Let's move forward. GDPR. No ideas? Yeah. Thank you. GDPR is a General Data Protection Regulations that were signed by European Union, European Parliament, and the regulation will be active since May 2018, half a year. And it defines what is a personal data, and it demands data controllers to implement data protection by design and by default. Moreover, GDPR says that there are a set of fines, a set of sanctions to those data controllers that are not even trying to protect personal data. This is something that deals with you and me, with all companies that work in EU. What is this? Do you know the story behind Equifax? What is Equifax? Security, identity, yeah. Equifax is a credit bureau from US, and they experienced a massive data leakage several months ago. Credit bureau, what kind of data they have? Basically, they have personal data of people. Name, surname, home address, social security number, driver license, etc., etc. All this data, million of records were leaked in a plain text. And this data is used by banks, by insurance companies, by other companies to identify users. Why we are talking about all the things? Well, because it's all about us, right? But you are really doing good. Thank you for all your efforts. You deserve a kitty. Yay! 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 We are good. We know about security. Yay! Basic things. Let's move forward. So, where we are. We all have sensitive data, right? But what do we do with it? We put it in a cloud. What is a cloud? Is it a magic place? Is it another universe that guarantees data security? No. It's just somebody else's computer that runs somebody else's software and is being maintained by somebody else. And what do? We put our personal data on somebody else's computer. Do we trust them? And what is more important, do we want to trust them? No, obviously. We don't want. We don't want to know how secure the cloud is. We don't want to read their policies, their guarantees. We don't want to understand their SLA. And of course, we don't want to think what will happen when this cloud will be cracked and our personal data will be leaked. So we don't want to think, we don't want to trust, we don't want to know everything, right? What do we want? We want to be like those kitties, sitting somewhere in a corner in a tinfoil hat. They know nothing about data. They know nothing about clouds, about data protection, all the things. And they don't want to share anything. Who wants to be like this kitty? Me, I want, yes. But yeah, we don't want to share anything, and not because we have something to hide. Not because we are paranoid, but because we choose not to share every single detail of our personal and work life, right? But we must. What is in common between your medical records and your credit history? Sorry, more loud, please. Yeah.
Current state of life.
Current state of life, yeah. Well, right. These all are your personal data, your sensitive data that is being shared to someone. And on some point, it must be shared to someone. For example, you do want to share your allergy list or your history of surgery or your x-rays to the emergency doctors that came to your house or put you in a hospital, right? But only to some particular doctors in some particular moments of time. It means that we want to control. We want to control what we share, whom we share. We cannot trust by default, and we don't want to think about security all the time. We just want to be like those small kittens. But we choose to retain control over sensitive data when we store it and when we share it. The question is how? How to control our data? Well, encryption is a naive answer. It's totally correct, but it's a naive answer. It's rather easy. Encryption helps you to solve some problems, and actually it creates more problems, but it helps you to solve some problems for some particular use cases. For example, when we are talking about messaging, we often use end-to-end encryption. And as we talked before, apart from the clients, nobody can read your secret communications. Clients have means to verify trust to each other and to the server, and to understand that cryptographic protection is working properly right now. End-to-end trust without leaking anything on the storage layer or transmission layer is the base of zero-knowledge architectures. I'm sure you know a lot of examples of messengers. They use end-to-end encryption, right? Yes. Can you name some messengers? WhatsApp, Signal, Telegram, Facebook secret chats. Line? Not sure about Line. BlackBerry Messenger, yes, probably. Yeah, you know them. You know them? It's quite popular because encryption solves problems for this particular use case. Let's talk about authentication. In authentication, we have this nice and shiny interactive crypto algorithm is known as zero-knowledge proof protocol. It helps you to compare a secret shared between two parties without transmitting this secret over the network. If you don't transmit a secret over the network, it cannot be leaked during transmission. Smart, right? If you don't know what zero-knowledge proof protocol, how zero-knowledge proof protocol works, it's okay. I won't dig into details. I can recommend you to read that post, or I can answer your questions after the session, or you can ask them me like privately. I just have a lot of things to talk. I don't want to stop on this one. The thing is that messaging, okay. Authentication, okay. But we want the same for our data. We want something more than just peer-to-peer relationship. We want to store it encrypted, but yet to share it, to manage access to it. And in a way like those kittens, if server is hacked, if operator is dishonest, we just say meow and move on. It doesn't make harm if server is hacked. So now we got to zero-knowledge architectures. Zero-knowledge architectures is a design principle. In a simple words, everything you do on your clients got encrypted to the server, and keys, your encryption keys, don't reach the server. So for servers, this data it doesn't know the nature of this data. Saying server, I mean anything apart from the clients, apart from the data owner. It can be storage, it can be web server, it can be any kind of environment, anything. And zero-knowledge architectures, the first layer, the first step in implementing zero-knowledge architecture is to make end-to-end encrypted clients, which means that clients became a fat clients. They do a lot of cryptographic computations. And as I told before, server knows nothing about this data. Sometimes zero-knowledge architectures are also known as no-knowledge architectures, because everything is on the clients. The second step is that all operations over the data is being computed over encrypted data. If you want to add new record in your database, you add it encrypted. If you want to update it, you update it encrypted. If you want to share it, you share it encrypted. And even if you want to search through your data, you search through encrypted data. Zero-knowledge architectures is not rocket science, it's a known principle, and there are several use cases where it works really, really well. And there are some use cases where it doesn't really work well. For example, let's talk about sharing data. Imagine you want to share one large piece of data to 5 users. But this is a piece of super sensitive data and it's encrypted, and the naive approach for your site is probably to encrypt it 5 times per each user, to encrypt it with different keys, right? Unique keys for these users, to distribute these 5 different encrypted blobs to each of these users, to distribute keys, and it leads a little bit to the data duplication. And from another hand, what happens if you will like to update this data, or if you will like to change the access rights? You need to decrypt it, encrypt it again 5 times, send it again with different keys, right? Does it sound like zero-knowledge architecture? Yes. Does it sound simple? No. However, it's a totally valid approach of sharing encrypted data. There is more on that. There are better approaches. For example, you can split your data into different blocks and provide access to exact blocks to some users. In this case, accessing or encrypting or re-encrypting only the access block of the user, not the data block itself. As implementation of this approach, there is an open source library called Hermes. It's still not published yet, because instead of writing code, I am speaking here. But it will be published in next week or 2. This is a great example how to share large blobs of data to multiple users without data duplication. Why we should care? Why we should care at all about all these things? First of all, because unfortunately we are not that kittens. We are not those kittens, we are mobile developers. And our users use our applications, and if we want to build zero-knowledge architecture in our mobile apps, we do interact with users, and our apps should run a crypto code, and you know that mobile is kind of trusted environment comparing to some browsers and desktop clients. Of course, it's not without risks. For example, if your device is jailbroken, if your device is rooted. Fortunately, we have things like Secure Enclave that helps us to do encryption. Unfortunately, we as developers always tend to put secret keys in our code. Let key equal quotes and the encryption key, right? Increasing the risks and making all our encryption practices quite useless. However, people are interacting with data on our devices, and we are the best people to implement zero-knowledge architectures to protect our users and their data. Mobiles are good clients, brand. Okay, after we heard a lot of these super exciting theoretical things, let's move into practical examples, right? Imagine a real world where you're a cat. But as a cat, you live in a cruel world where you have a credit history. This is an example of credit history. I made it up, but it's based on real credit histories. So it consists of several blocks. First block is a personal data block. It contains name, surname, street address, social security number, pet name, all the things that are used to identify that you are you. The next one is a credit score or credit rating. This block is a kind of protected data because banks and other authorities are use it to decide whether to deal with you or not. And the last one is a list of your transactions, list of your communication with those banks, with timestamps, with money amounts. This is a thing that you really want to keep protected because it reveals a lot about you. And this is a scheme of relationship between Mr. Cat, bank, and credit bureau. So guess who has Mr. Cat's personal data, a credit history data in this scheme? Sorry? Not really. First, it's credit bureau. Credit bureau stores all the credit histories. So imagine Mr. Cat came to a bank asking for a loan. Like, I want a loan, I want money. Bank sends a request to the credit bureau asking for a credit history of Mr. Cat. And of course, the bank needs to identify Mr. Cat somehow, so it uses its name, surname, social security number, all this, some of this personal information. Credit bureau has this request, and the easiest thing it can do is sending all the information to the bank. Easy. Sometimes banks ask even more information they need. Sometimes they ask everything about you. However, it's not the first bank Mr. Cat is dealing with. He had a long life, so he dealt with different kind of banks. And imagine that all these banks eventually sent requests to the credit bureau, and now they all of them have copy of personal data and credit history of Mr. Cat. What could possibly go wrong? No, really. You have Mr. Cat and his personal data circulated among all those authorities. Well, a lot of things could be wrong. First of all, when bank is cracked, all personal data is leaked. Even if the personal data credit history is being encrypted, fortunately, credit history is encrypted. However, usually it's encrypted with symmetric key, and all credit bureau do, they send encrypted history and key to the banks. So, even if the history is encrypted, but credit bureau is distributing the keys, when some bank is cracked, the key is leaked, and all the history may be decrypted. Then, dishonest credit bureau or banks can accumulate more data than they should, and they can misuse the data against Mr. Cat. For example, banks, as I said before, banks attempt to request all credit history, like for last 10 years, although they don't need it. But they request it and they accumulate it. Next, banks are judging Mr. Cat or you based on the knowledge they accumulated without even your consent. For example, do you remember that stage when Mr. Cat came to the bank and bank sent requests to the credit bureau? The credit bureau accumulates all these requests from different banks where Mr. Cat went, and now it has a history of requests, and now it can understand which banks has rejected Mr. Cat and how desperate he is, and change his credit score accordingly. This is indirect data. No one sends this data directly to credit bureau. This is something credit bureau can calculate based on other data. Moreover, do you remember when bank requested the credit history? It sends the name, surname, social security number of the network. Even if it was the first bank in the life story of Mr. Cat, and credit bureau didn't have any credit history of Mr. Cat, after this request, it has name, surname, social security number, and it accumulates everything. So next time it will be able to identify Mr. Cat. Moreover, this is a nice place for replay attack because they're sending all this sensitive data over the network. The question here is how zero-knowledge applications have zero-knowledge architectures can help us in this scenario. Well, first of all, imagine that all the credit history is being encrypted. Then, as soon as different users in our system need access to different blocks of data, we can divide credit history to different blocks, right? For example, the personal data is read-only for banks. The credit score is read-only for banks, but read-write for credit bureau. The transaction log is complicated Because you don't want to share access to all your transactions during the last 10 years, even if bank wants them. You can decide to share access only for 3 transactions, for example, read-only access. And of course, you don't want to share read-write access for all of these transactions. Each bank should be able to update only its unique transaction, right? So we are splitting encrypted history into blocks, and we are managing access to each block separately. And everything is encrypted and controlled by a data owner. How this scheme is changed? Now the Credit Bureau stores encrypted data, and if, when it will be cracked and the data will be leaked, it's encrypted. Then banks have their own unique keys only to some data blocks they need. So when banks will be cracked, only part of information can be leaked. And of course, there is also some institutions that don't need access anymore, so the data owner can revoke access, and it doesn't mean to re-encrypt all the data. This approach is quite simple, and it works on several, you need to perform several steps to make it work. First of all, decouple storage keys from user keys, right? So we have storage and stored encryption, and user keys, the access to the storage. And these are different entities. Second, store storage keys in containers and control them by these user keys. So if you want to change access, you don't need to decrypt and encrypt data again. You are working only with small access block, not with a data block. Then, since you are working with encrypted data and all operations should be with encrypted data, all you need to do is to make sure that all your requests from your applications, from your servers, everything goes through the crypto layer. That no one will go straight to the database and no one will put any plain text data in a database. This is super important when you are building this kind of system. And of course, cryptography is not something super magical. You still have a lot of risks. So your system still need those, simple things like monitoring, like ensuring code trust, like managing keys, don't put keys in a plain text in your code, etc., etc., etc. Thankfully, most of these things are already solved on a high level, so you don't need to do any crypto math. Let's talk about risks that Mr. Cat is suffering from. We talked before about data leakage. How we solved the data leakage? Easy, data is encrypted. What about privilege escalation? Do you know what is privilege escalation? When you can get the root access to the server, and you can get the access to the database, and you can update your user role in a database, like to owner to data owner, just because you have hacked and you have rooted the server. But in our case, as soon as access to the data is being maintained by crypto keys, by access keys, it's impossible to root the server and to get access to the data. You still have the cryptography layer there. What about replay attack? As I talked before, as soon as we are sending a lot of data in the network, we can accumulate this data and use it lately. Well, we are solving it thanks to the zero-knowledge proof protocols that don't push you to send data over the network. You can compare data without sending it if you already have it on both ends. So in our example with a bank and credit bureau, when bank sent name, surname, and social security number, bank and credit bureau creates a new record if it still doesn't know Mr. Cat. Using zero-knowledge proof protocol, they don't need to send all this data over the network. Bank just asks credit bureau, do you know the guy who looks like Mr. Cat, without sending his private information. And if credit bureau doesn't know this guy, it just cannot prove it does. So they're not sending this is a kind of super simple explanation of zero knowledge proof protocol. They're not sending the private data over the network. They assume if both parties already share the data, they can prove that the data is shared. If one of the party doesn't have the data, they cannot prove it. So, and what about other risks? As I told before, there are a set of tools like monitoring, checking connections, traffic inspections, etc., that you still need them, and code police, right? You still need them to make sure that your system is working good. There is this example with data is a really nice example, but with your credit history, but it's not the only one. Actually, you can use this approach when you have any kind of large collaborative document. This may be large audit log files, it can be large config files of your servers. Well, okay, we are mobile developers. For us, it can be spreadsheets with comments, something large that can be divided into blocks, like a file system, and something where you can manage access to separate blocks. And the question that we are really interested in, right? How difficult is it to implement? Well, you already know that what you need to do. You should create really fat clients with a lot of cryptographic computation on them to make sure you need to design your system so it is end-to-end. You need to make sure that no keys are leaked from the clients, and you need to make sure that all operations you do it on encrypted data. How difficult is it to implement? Well, it depends. This is a small, super small code from Axolotl, from the protocol that Signal app is using. And this is a super custom, super specific implementation for their use case. You don't need to write all this thing. If you have already existed primitives, if you have already existed high-level functions. This is an example of I shown on Swift Alps workshops a year ago. This is an example of end-to-end application on Swift and a Python as both ends, and it's based on another library that is open source, another library that provides a tool for storing data securely and for sending data securely. But still, it requires some work. And this one, the library I talked before, that is still under development because I'm staying here instead of writing the code. However, it's almost done. This is a perfect solution for the use case of the large documents and blocks and managing access to the blocks. It has a C core, and the C core is done, all tests are passing, the cryptographic paper is being reviewed by huge cryptographers, but I need to write an iOS example, and I'm staying here. However, if you like my talk, it will increase my efforts in writing all these examples in open sourcing and sharing it. So no worries, I will do it eventually. Of course, there are other existing examples outside of our shiny mobile security world. The first one is LAFS. This is a distributed file system where you can store files securely, and actually it splits files into different blocks to different servers. So even if one server is hacked, it has just small chunks of data, encrypted data. And another one is really cool. This is ZeroKit from Trezorit. And ZeroKit has integration with CareKit. It's still in beta, but you can sign up for beta. And personally, I find it really, really interesting and really, really exciting to see what happened. Because, integration with CareKit sounds really cool. Okay. Good, you're here. I see your eyes. You deserve a kitty. A small recap. Zero-knowledge architecture is a design approach that solves problems that we have. Some of these problems can be solved rather easy when we are talking about peer-to-peer communication, when we are talking about messaging, when we are talking about authentication. Unfortunately, there is no easy solutions to solve problems when we are talking about data collaboration. However, there are a set of instruments you can use. And the thing is that we continue collaborating on data, and we continue collaborating on personal data, on private data. So for the sake of our users, for the sake of our products, we mobile developers are pushed to use this kind of approaches to make our products even better, right? I know that it's not enough for you. I know that you're super interested in security, and I know that you want to learn more. So I have prepared a set of links for your home reading. You know, long winter nights reading about security. This set of links is more about zero-knowledge architecture, zero-knowledge approach. It's not a unique mobile approach. You can use it anywhere. Detailed description about zero-knowledge protocols. And it's not everything, of course. You can read about encrypted Git. This is a brand new one announcement from Keybase.io, just from yesterday. Check it out, it's really cool. And if you don't really understand how end-to-end encryption works, you can check Explain Like I'm 5. If you feel that is a little bit high-level talk for you, you're not ready, there are many other low-level security talks I gave, more practical probably for you. You may find them interesting if you like. Each of them also has a set of links for your home reading, so if you will open every link, I think your winter will be like with a book or with a laptop. Okay, thank you. I still have those nice stickers, so if you ask me questions or if you won't ask me questions, I still have those stickers. So, feel free to ask me questions right now, feel free to ask them to grab me somewhere and ask them later, to ping me email, Twitter, etc., etc., etc. I can help to solve some cases you have with making your apps more secure. Thank you.
Questions?
Questions, stickers. Okay. I have a question for you. Who wants a sticker?
Hello. What do you know and what do you think about the self-sovereign identity? You know, when you can use the ledgers encryption to save your profile, all your data, personal. Have you worked on it or not yet?
Do you mean the idea of
the ledgers and the self-sovereign identity? You know, the encrypted profile of all the data, all the stuff.
No, I haven't.
Okay.
I'll check it out. Thank you.
Yeah.
Will you publish the links on Twitter, maybe?
I will publish the whole slides on a speaker deck, and I will publish a link to the slides on Twitter. Yeah, so no worries. You will have a lot of chances to look them through again and to press on all these links. Anyone else? Yes?
Hello. So you were talking about this bank data, finance data, and I am curious, what do you think about this blockchain technology when you can check all the history of the public wallet?
Blockchain. You're making my presentation in a buzzword presentation. I was trying to avoid this. Okay, so blockchain. I think that blockchain as a technology is really great because you can prove all the transactions, right? But I like blockchain. What I don't like about blockchain is the idea to fit blockchain everywhere. It's not a silver bullet. It doesn't solve all the problems people trying to solve using blockchain. I really believe there is a set of problems that can be solved by blockchain, that is solved by blockchain and everyone is happy. But if we think about having all this transaction history and trying to collaborate on it, it becomes more and more complicated because you need to, to have copies of the blockchain, the tree, and you need to solve the conflicts, etc., etc. It's just a really huge amount of data if you think about it as about something you want to collaborate on.
Okay, thank you.
We should have a blockchain conference. Yes, please.
Hello.
Hello.
I get two questions. You were talking that this separated basis of blocks of data can be divided into parts, and each of the parts can be encrypted. Yeah.
More complicated, but yeah.
Yeah. What about using this technology to defend us on some ransomware attacks? I mean, in the context, you said that you are minimalizing attack surface, okay? But what in the case when the attack vector is advanced persistent threat that already occurs in the company? And let's suppose that you are encrypting this data on this data block on a particular server, and then the miscreants are doing their dirty tricks and encrypting it again with ransomware. So what about the whole data when one block is encrypted by invading software?
You mean what will happen if we encrypt one block of data by malware, right?
Correct.
Well, it means that everything will be hacked. I mean, what you need in zero-knowledge architecture, the main idea is that you trust the code that is being running on the client.
Mm-hmm. Okay.
And clients are the parties that do all these crypto computations. So in your case, if you don't trust, if some client is hacked and they have access to this blob of data, fortunately to only one of them, not the whole data, if the client is hacked and if it can run the malicious code, yes, you're right. You will just lose one block of data.
Well, just only one block of data, okay. And what about other blocks? They are readable in the normal way, but without this one block which has been encrypted by ransomware, yeah?
I think now we'll start discussing something like really deep. Again, the idea is that you run all the computations on the client side, and you should trust the clients. If at least the environment where you run this code. If this environment is hacked, if somebody is changing the code that is encrypting and decrypting the blocks, yes, any blocks, you are kinda hacked, right?
Okay, thank you. We'll definitely talk it over on some one-on-one meeting.
Okay. I see one more hand. I think that will be the last question, okay? Yes.
Hi, thanks for the talk. It was very interesting. Companies like Apple, Google, Facebook, they use our data to run their business with our data. So I wonder if it's possible to apply something like this in a way that we can give them the data. It's kind of encrypted, but they still have access to some sort of information or score about us, and they can run their business with our data encrypted. Is that possible?
I'm not Apple, I'm not Google. From technical perspective, yes. From technical perspective, this is a cool approach when you're sharing your data between different parties, right? And when you want to control what exactly to share to which users. From technical perspective, it's totally possible. The question is whether those parties are okay with that, whether you can implement all the system. Because when we are talking about even credit history, it can be done. It's actually done. It can be done in some particular countries, for example, in a small scale. When we are talking about large scale, like companies like Apple and Google, questionable.
Okay, thanks.
Thank you. Thank you for your questions. Let's continue in like one-to-one, okay?